So good morning to all the participants. Today we'll be starting our next session, our first session. Hello. So
Good
before
morning, sir.
starting, good morning,
Yes, sir.
Dr.
Good
Madam.
morning. Good
Okay.
morning, sir.
So shall I take first attendance? Shall we start with
Okay, sir.
your attendance first? Because almost
Yes,
all
sir.
the
Okay, sir.
participants have joined now, and our guest speaker is also joined. So Dipti Malviya, Dr. Dipti Malviya.
Yes, sir. Yes, sir. Present, sir.
Yes, very good. Dr. Vishali Parki,
Present, sir.
Miss Neetu Amlani,
Present, sir.
Dr. Nirav Pandya,
Present, sir. Present, sir.
Mrs. Minal Rajdev,
Present, sir.
Dr. Suparna,
Present, sir.
Dr. Amit Kalbande,
Present, sir.
Dr. Archana Mahakalkar,
Present, sir.
then Dr. Vinod Dongarwar, Dr. Arvind Somnathe, Dr. Shruti Gharde, Dr. Pallavi Deshmukh,
Present, sir.
Dr. Minakshi Kamble,
Present, sir.
Dr. Shil,
Present, sir.
Mr. Vivek Manik, Mr. Vivek, I think he's yet to join. Dr. Rajesh Sonkusre,
Present, sir.
Dr. Vishal Daulatkar,
Present, sir.
Dr. Swati Yadav, Mr. Kerakata,
Yes, sir. Present.
Miss Kani Mozi.
Present, sir.
And now you will have to shoulder the responsibility of Dr. Kartik sir. Huh?
Yes, sir. Yes, sir.
Let me start first, and then I will hand over the question to you.
Okay, sir.
So our guest speaker has also joined. The name of our today's guest speaker for the first session is Dr. Kartik. Basically, he's a civil engineer, B in civil engineering from Bhopal University. Then he did his ME in environmental engineering from Anna University, Chennai. And at present, he's pursuing his doctorate degree in one of the topic and in environmental engineering. At present, he is working as a senior principal scientist at Training and Skill Development Division, Niri Nagpur. His area of specialization is environmental impact assessment, wastewater management, and climate change. Today, he has decided to deliver his presentation on approaches to address the impact of the climate change on water resources. So, on behalf of Sevadal Mahila Mahavidyalaya and on behalf of UGC HRDC Center affiliated to RTM Nagpur University, Nagpur, I would like to welcome you, sir. Now, I would like to request Ms. Kani Mozi, please proceed for your today's introductory program.
Okay, sir. A pleasant morning to everyone. I'm very happy to introduce our resource person, Mr. M. Kartik sir, who is the principal scientist in the Environmental Impact and Sustainability Division, CSIR Needy, Nagpur. Sir has completed his BE in Civil Engineering in the year 1996 from Batkula Vishwavidyalaya, Bhopal, and he did his ME in Environmental Engineering in the year 1999 from Anna University, Chennai. Currently, sir is pursuing his PhD in Environmental Engineering in ACISIR, Nagpur. His area of specialization includes wastewater management. Sir has to his credit of nearly more than 10 scientific publications in various reputed journals, and he's also contributed a chapter in ISBN edited book. Sir has also contributed to communications. He has given several invited lectures on wastewater management and environmental engineering at ACISIR Needy, Nagpur, Academic Staff College, Nagpur, Ordnance Factory, Nagpur, and the National Power Training Institute, Nagpur. Before entering into NEERI, Sir has previous work experience at Varpura Gases Limited, Chennai, as well as he has been working in Laws of Ecology Authority, Chennai. He has even traveled to countries like Egypt, India 2013 and to Thailand in 2014 regarding his work. Sir, we are very much eager for your session, sir. Now the forum is to you, sir.
Thank you, Dr. Praveen, for inviting me for this refresher course presentation. So, and I thank Dr. Kanimuri also for this nice introduction. Okay, so before I start, just I would like to add, I think the topic today it was chosen is that the importance of that in the current context. Like we can see continuous impact on human activities on climate in terms of flooding, droughts, happening frequently in comparison to the earlier, in the past. Okay, so in this context, when you say climate change, is my voice clear? Is my voice clear to all?
Yes, sir. Yes, sir.
Yes, sir.
Okay, because there will be some words which you can't, it may become inaudible when you are doing online kind of presentation.
sir.
Okay,
It's not clear.
it's not clear. Okay, I'll
No,
raise the
sir.
voice. Probably, I think anytime you can feel that there is a drop in voice, you can let us know because there is a internet problem. I have connected to Wi-Fi, so probably there may be sometimes this can happen. Okay, am I audible now clearly?
Yes, sir.
Now you are
Okay.
audible, sir.
Okay.
Yes, sir.
Okay. Now I'll raise the voice and speak. Okay. So in here, when we see climate change, the most important aspect of climate change, what humans perceive is the temperature and water. So being a civil engineer myself, I deal with the design of sewage treatment plants, sanitation, water resources development. So from my perspective, or in general, human what is the most important thing in fact or when it is a flood. So in this context, the presentation is made to address this topic. So when we see climate change, when we see climate change, everybody thinks from their perspective and their competency. So a farmer can think from the perspective of failure of crop as climate change. He may say that the rain should come today. It is not coming on right time. Okay. So when we say climate change, each one will think from their own perspectives based on their needs and requirements. So, but scientifically, the definition is given like that. Climate change is the long-term alteration of temperature and typical weather patterns in a place. So, climate change would refer to a particular location or the planet as a whole. So, it can happen as in the entire planet, or it can affect regional levels. So, there is something called weather. So when we say weather and climate, it's slightly different. So weather is something which is instantaneous, on the spot, and it can keep changing, immediately. And it's something like morning, 5 minutes before it may be raining, and 10 minutes later it will stop raining. Weather is something instantaneous at that point of space. Whereas climate change is long term, and it is a global kind of phenomenon or regional kind of phenomenon. So how weather is defined as weather is the day-to-day state of the atmosphere. It can be in minutes, it can be in hours, but it is in a small time frame. When you see the time frame, it is normally minutes, hours, days. But when we say climate, it is months, yearly, then decades, and 100 years, 1,000 years, million years, like that. So this is a small difference. It's the equivalent example how I can give is now if most of you people must be having two-wheeler or cars. So there you can see that the mileage measurement they have a instantaneous mileage, how much petrol is consumed per kilometer, how much kilometers is consumed by the vehicle, or petrol consumed So there are two components in that. One is instantaneous mileage, and the other one is the average. Okay, so this weather is something like instantaneous mileage. Climate is a long time. So this is one example which we can quote with respect to weather and climate difference. So over a period of time, the weather has, the average temperature of the planet has increased to 1 degree. Right now, the temperature has increased by 1 degree. So in another 20 to 30 years, they expect it to reach 1.5 degrees. So newspapers, all research works, they're all saying every day that everybody is living on the comfort zone. Like we may be thinking that for any average human being, if the number of hot days is increased, then they will say that the climate has changed. If the number of rainy days has increased, we say that climate has changed. So before going into the depth of water, flooding and drought, we need to know what are the things which are connected to this climate change topic. So the average temperature has risen by 1 degree in the last 50 to 100 years. So there are a lot of probes and satellites which take the measurement across the planet and then they average it. Okay, the most important reason why climate is changing in the context of climate change is the rising heat. So it is connected to the global warming. So now global warming, how does it happen is because there are a lot of greenhouse gases which are contributed by the human activities such as transportation, agriculture, power production, industrial activity. So there are a lot of human activities which I said right now, they are all contributing to the rise in the average temperature. So when the global warming occurs, then this impacts the average temperature of the Earth. This is the kind of connection between human activity, global warming, and climate change. So you all must be seeing regularly the quantity of carbon dioxide is increasing, every year, every decade, every 100 years. So this contribution has increased and very dramatically in the last 200 years of industrialization. Industrialization, one reason why the CO2 emissions have, increased by leaps and bounds. So this slide gives, you can see that the total CO2 emissions in terms of billion tons. So it's about 35 billion tons right now, 35 billion tons and slightly higher, 37, 40 billion tons, you can say, of CO2. Okay, so you see that you can see in this slide there are contributions from various countries. So the industrialization actually started something around 1800, and now it has increased to such an extent that the quantum the start of industrialization, it was around 1 billion tons, something like that. Now it has increased by 35 to 40 times more due to the. You can see India's contribution in brown color, China in reddish brown color, and there are other regions like United States and Europe has been the largest contributor in the last 150 years. So India is catching up with that. You can see India's increase started somewhere around 1970s. So now you can see the brown shade of where India is represented. So you can see the increase, India's contribution to the total CO2 emissions.
Excuse me, sir. Sir, slides are not moving.
Yes.
Slides are not moving, sir.
Okay, it's already shared. Okay. Sure, meeting. Sure. This is problem with online systems. Now is it there?
No, sir, it's not visible.
Now is it there?
No, sir.
Uh, It is shared. You see it now? It's in share mode only for me. Now is it shared?
No, sir. No, sir.
Because it is in sharing mode. What is the problem? my God. So I'll do one thing. I'll have to stop sharing and then I'll rejoin because this kind of things happen. Okay. Can this be seen now?
No, sir.
No problem. It is in sharing mode. Now you can see that.
No, sir.
Maybe I'll shut down my video. Some problem. Is it visible now?
No, sir.
Uh, I am just told here, there's a comment here, you can't share content unless the host or a co-host makes you the presenter. Is it visible now?
No, sir.
What do we do?
Already we have made you as a presenter.
No, but actually, I have shared it. I don't know why the problem. Actually, it is sharing.
अपने करने का प्रॉब्लम नहीं है
Voice is clear, but I don't know. Share. It is already shared. It's showing me you're sharing the presentation. Mhm.
हाँ?
So is it now? Oof. Yeah, is it visible? Start video. Is it available now?
Now it is visible, sir.
Okay. Uh, okay. Okay. Now it is visible. So I'll just continue. Okay. Can I go ahead? Is it visible? Then I can move ahead. But I don't know. My screen, I am not able to control. Yes. Now is it visible? Is it visible now?
No, sir.
Yeah, it's visible.
Maybe I think a few of how many people are not getting, I'm not sure, but it is in sharing mode only. There is no other mechanism by which I can.
Sir, it's visible now, and you are on the graph slide where you are explaining.
Yes, exactly.
Uh,
Exactly. Okay, thank you. So you can see in this slide, there's about 35 billion tons CO2 emissions and country-wise also, all the gases. So now I'll go to the next one. So if you can see the in this slide, this pie chart gives the percentage contribution of major countries. Like you can see the largest emitter being China, followed by United States, European Union, and India. In terms of net GHG emissions. So we have so many gases: CO2, methane, nitrous oxide, HCFCs, all these things, all these gases are there. So the total GHG emissions, this calculation is based on the total gases converted into CO2 equivalent. Okay. So you can see the major contributors: China, US, European Union, and India. And the rest of the world is around 36%. And besides CO2 emissions, the bottom pie chart gives the emissions by sector. The largest emission comes from industry. So where iron and steel, oil and gas production, cement, chemicals, coal mining, and other industries are the major contributor. So that is why if you can't see, if you have to address the CO2 gas problem, we need to target all the emitters which are in the which are generating high quantum of this CO2, methane, nitrous oxide, HFCs, all these things. Okay. So then this industry is followed by power production. When India, most of the, about 70% of the power production comes from coal and natural gas. Okay. So there are other renewable energy is catching up in this last 2-3 years, last 10 years. So over a period of time, the CO2 emissions from electricity can come down. Okay. Then power production is followed by agriculture. Land use means how the land is converted. Earlier it must be an agricultural land or a forest. So when we are going for urbanization, you cut down the amount of trees in the area. You are building infrastructure, highways. All these things will remove the existing status of the land, and you will be using it for some development purpose, like putting highways, companies, all these things. So that will change the amount of CO2 absorbed or sinked by the system. So land use is one thing, and finally the landfills. The amount of waste which goes into solid waste which goes into the landfills. The landfills are also known to cause global warming because landfills generate methane, not CO2, methane. So methane, if you see the carbon dioxide equivalent potential, it's about 21 times compared to CO2. So each molecule of methane has 21 times the potential of carbon dioxide. So besides agriculture, we have transport sector. Like transport sector, most of them use fossil fuels, petrol, CNG, LPG. All these gases they leads to rise in CO2 amount of CO2 released from this sector. Then buildings also. Buildings. When we say buildings, from kitchens, from electrical equipments, all these things. So this is the emissions by sector. These are all already available across the web, where you can get an idea. If you want, you can go to the respective websites to get quantum of emissions. Okay. So now, if you see from engineering perspective, global warming is the first most important thing which we perceive. Okay, in terms of excessive flood, excessive flood, droughts, then because water is consumed by us. So then when this global warming goes on to change the climate change. When I said that global warming is equal to instantaneous mileage, so climate change is average of the instantaneous mileage. Okay, these two things can impact water resources over
Sir,
a
again,
period of time.
slides are not moving, sir, again.
Oh,
Slides are not at all visible, sir.
Actually, I don't know. Is it an internet problem? I don't know. I'm using internet from my mobile because LAN is having some problem. Okay, so is it moving now?
No, sir. So it is not visible also, not even moving, it isn't visible also, sir. We can only hear you. Now it is
Okay.
visible, sir.
Okay.
It's
Now is it?
moving as well.
I
Yes,
don't
sir.
know.
It's visible and it's moving as well.
Okay. Actually, I don't know the reason. Probably network related issues could be there. So, did you all see this pie charts?
Sir.
Yes, sir.
Okay. So I'm changing to the new one. Yes. So, okay. ठीक है. So this I have already explained. There are a lot of heat trapping pollutants, especially carbon dioxide, methane, nitrous oxide. So the amount of these gases, which when they increase, they will increase the heat retention capacity of the atmosphere, and that's how the global warming happens. So average temperature of our planet was somewhere around 18 degrees. Now, over a period of time, when we contribute more of these gases, the average temperature keeps on rising. Okay, so yeah, this carbon dioxide is very much important to maintain our atmospheric temperature because they give the otherwise Earth would be a very cold planet. So, all these greenhouse gases are very important for life sustenance, but the increasing concentrations of these gases are known to cause global warming and subsequent events. So the first and foremost thing is that extreme weather events which can happen like excessive rainfall. So when you have excessive rainfall, you have changes in water cycle patterns. Then excessive waterfall can lead to contamination of existing water bodies. When you have drought, when you don't have rains, then drought it can have an impact. So most of this impact has increased very extensionally in the last 20 years, from 2001 to 2018. Okay. So next slide will give various international conventions with respect to climate change. These are there, and each one has their own an area, uh, what their mandate and their objectives. Okay. So, as per this sustainable development goals, we have 17 sustainable development goals. All these are connected to climate change and water directly and indirectly. So now you see the first one is no poverty is the first sustainable development goal. So when you say no poverty, that means you have to produce food, and when you need to produce food, you need to have water. Then zero hunger, it's connected to water. Good health and well-being, of course, sanitation is very important to good health and well-being. Quality education, of course, education comes after you provide the first three. Then gender equality, then clean water and sanitation. Of course, it is connected to the water. Affordable and clean energy. Our energy is produced from fossil fuel, which also uses water for production of steam. So to produce steam for our fossil fuels, we need to have water. So again, this availability of water can affect clean energy. Oh, sorry, energy, affordability of energy. Then, of course, your quality of life is dictated by the amount of water. Industry directly dependent on water. Reduced inequality, sustainable cities and communities. Sustainable when you talk about sustainable cities and communities, you need to provide them with minimum quantity of water to provide sanitation and hygiene. And responsible consumption and production, of course. These are not directly connected, but water is always connected to all the 17 SDGs. Climate action, life below water, life on land, peace and justice, strong institutions, partnership to achieve goals. So why all this is connected to water? Because once water is not available, it can impact us in direct and indirect ways. It is it can impact the socio-economic studies, socio-economic activities in such a way that none of these 17 things can be achieved. So far, we are able to achieve only a few sustainable development goals, but the target is to achieve almost all in the next 20 to 30 years. So how do we achieve it? Now, when we say climate change and how impact on water resources, how are we going to achieve it? So we need to manage our global warming issue. We need to do some kind of studies. First thing is that we have to study the impacts caused by these gases. Then impacts will have some responses. So the responses we have to mitigate as well as adapt. Because you can't, why I'm saying adaptation, because once you impact the climate in such a way, even after mitigation, it's not going to return back to the same state. So there is a need for adaptation. New scenario will be created. Though we may be addressing most of the issues with respect to CO2 gases generation or pollution, all these things, but adaptation is important. Otherwise, again, the 17 sustainable development goals may not be achieved. Okay. So we have any government projects which is working on climate change will have these three main notation. One is climate change impacts, mitigation, and adaptation. Every government which is working for this climate change program, they have this impacts, mitigation, and adaptation. So our policies will be working on all these three components: impacts, mitigation, and adaptations. So mitigation means refers to the actions to reduce greenhouse gases, like switching to renewable energy such as solar and burning fewer fossil fuels. This is one approach. There are each areas we can have mitigation aspects to address to reduce these greenhouse gases. Then adaptations. Adaptations are actions that manage the risks of climate change impacts, like building resilient infrastructure. Okay, you need to adapt it. Otherwise, whatever has changes have occurred, we may not be able to have a better life with the new environment. So is my slides moving?
Yes, sir. Yes, sir. It is moving.
Okay. So, how does climate change affect? Yes, climate change impact societies, economies, ecosystem. So these are 3 points we always look. Being a technical person, I look only into the technical aspects of the climate change studies. Where I'm working with the MOE. I had done inventorization of greenhouse gases from waste sector, waste sector. Our director, Dr. Atul Narayan Vaidya, has worked on this in the solid and industrial waste, whereas I worked on the wastewater aspects. So we have to inventarize the amount of greenhouse gases, especially CO2, methane from wastewater. So when you see that this is going to impact society's economies and ecosystem. So when we say climate change, now you all may be observing the last few days it has been raining like cats and dogs in the north as well as in the Mumbai region. So these are all extreme weather events. One year if it is raining very heavily and next year it is a kind of a slight drought, and we can't say that's climate change. Climate change is something beyond that, which is going to impact the average in such a way that you can't have any surety when is this season going to start. When you have a normal season, it will start with plus or minus in 1 or 2 days. You can't have an exact date by which rain will enter Nagpur region like that. So there will be 1 or 2 days. So everything is calculated in terms of calculated with uncertainties. This much percentage of rainfall will occur based on the average. So this year, I think it is predicted there will be a kind of below normal level of average SSS, something around 90-95% has been estimated. So these can lead to extreme weather events, biodiversity loss, increased health risk, and displacement of people. These are 4 points which every government's administration or local bodies, they have to take care. So if you see disaster management plan, we have given lecture for disaster management plan also. So there, how they handle floods, drought and all. So these are some events where we see that water is the most important thing, which can impact us. So that's the reason why this presentation is provided. It's not going. Yeah. Okay. So can you see the pictures?
No, sir.
Can I see? Okay. So
Now it is visible, sir.
these are so many events which are occurring in the country. Okay, so that's just give a introduction about what is the things happening the last 20 years. As I said, from 2000 onwards to 2022, 23, the amount of extreme weather events have increased. So you must have seen these videos across the news channels like that. So what is the reason why it is happening? The main reason I have given here is urbanization. So, for a flood or a drought, if you see, urbanization is one major important thing which is affecting the problem very significantly. So, you can construct the roads, all these things, you are blocking natural channels of flow of the river. So you are making when water can permeate soil. So when we completely put cement or impermeable surfaces, so what happens is that where is that monsoon water going to go, rainwater going to go? So it has to flood somewhere. It will go to the nearest low-lying surface. So urbanization is, assumed to be the major factor in causing impacts of climate change. So we have climate change, but the most our problems are compounded by urbanization. Okay, the point is that climate change is happening. Humans are causing a lot of increase in gases that is impacting, but our problems are multiplied due to urbanization. Urbanization is the most important thing. If it is though we may be increasing the CO2 greenhouse gases, what is happening is that urbanization can compound the effect of this climate change impacts. So flooding, droughts are all one major reasons. Okay, then the second point is human population. So the population in 1800s was almost total population of humanity is something around 1 billion. So right now the population of humans is around 8 billion. 8 billion. Imagine 8 billion planet people in this single planet over a period of last 200 years. So human population is, a second major factor for compounding the effect of climate change. So why I'm saying this is because every human requires some amount of food, clothing, shelter, and luxuries. Of course, if you are a poor person, then the luxury you can remove it. But everybody needs food. Okay, so when the quality of living or standard of living increases, the these things which I told luxury. So you touch the height of our need. Okay, so basically every human needs only food, shelter, and clothing. But when the quality of life has increased, the fourth component, that is luxuries. So that increases, geometrically. So when everybody needs luxury, it becomes a additional problem to address the climate change impact. Everybody wants car. Everybody wants to travel by plane. So these are all our needs are actually putting a compounding effect on the climate change. The third one is unplanned. Of course, if you see the developed countries where the population is very less, so they can plan their activities very well. They can put roadways, they can put proper measures to address flooding as well as drought systems, because they have less population, they have less amount of luxuries needed, or less in infrastructure, less inputs needed for the population available. Whereas in India, we have whatever space we can't put roads everywhere because there are people living around. We have agriculture as one of the major component of our economy. So if you see, most of the times in India, we have unplanned kind of growth. It was happening. Now there is a kind of planning, but that's a different thing to address here, and it's not the place to address here. Okay, then we have unsustainable growth. Yes, from 1800 to 1950, the population of world was growing in a very lag phase manner. Like in microbiology, you must have heard the term lag phase, log phase, then this thing, steady state, all these things. So human population also grows something like this. Now we are in a kind of lock phase where the population has grown in the last 50 years in a terrific way. So all people has to be provided with their needs. So all these things factors actually compound to the disaster. It's very difficult to address this issue if you are not able to address these four components. So we have problem. If you have gone to Srinagar, you can see wetlands in Srinagar, Dal Lake and all, no, they have shrunk. So I was part of the study how to address this issue. So that's why the pictures are here. Okay. So even all the beautiful places in the country now, because of tourism, urbanization and tourism, they are losing their glam and efficacy. They are disturbing the local environment. So now you see this in this table, you can see this since 1970s to 2022. See the number of cyclones happening. It has increased definitely. Of course, the deaths during those times were higher. There is a reason because India was not prepared properly. Less amount of education. All these things were government were new. All these things are there. But over a period of time, we have learned from our mistakes, and you can see though we have reduced the number of deaths due to cyclones. If you see droughts, yes, there are some places which has been impacted by droughts. You can see Maharashtra is one place where you have regular drought-like situation. We have hotspots like Ahmednagar, Anandpur, Aurangabad, Bijapur, all these things. This actually the places mentioned here are from Maharashtra and Karnataka. So these are about 68% of Indian districts has been facing droughts and drought-like situations, and this will be impacted much more, and the number of cities and towns will be more in the future with respect to droughts. The same thing, droughts and floods are happening simultaneously. There are flood prone districts like Cuttack, Guntur, Kurnool, all these things are having flood prone. And they have a drought also in the subsequent years. Now we need to engineer a system in such a way that we have to reduce the flooding as well as reduce the drought. So that's how engineering comes into play, engineering and management comes into play. So if you see coastal southern states, mostly coastal areas, this is a problem of flooding, especially Andhra Pradesh, Tamil Nadu, Karnataka. They're witnessing floods as well as droughts. The reason is that when it is raining, because of urbanization, too much impermeable surfaces, so flooding is happening. And because we have covered all the surfaces, no water is going into the aquifers. And then now we are faced with drought or less amount of water. So this is all our own problems which we have created in the last 150 years of industrialization and indiscriminate human population. Okay. So these are all the, you can see the orange highlighted parts are all drought areas, and the blue ones are all flood prone areas. So this map gives where cyclone, you can always see that cyclone is affecting the eastern coastal region, Tamil Nadu, Andhra, Telangana, and Orissa. You will find during northeast monsoon, so you will have, southwest monsoon, you have impact on these areas. Okay. But you don't find a problem in North India where the population is low. If you see in entire India, we have a drought situation. Somewhere, sometime we have a less amount of water during the summer season of 3 or 4 months. Okay. So now this slide is the per capita water availability. Now, when we say that water resources, how it has changed over a period of time, per capita water availability. So every country water resources are calculated by the water departments like Central Water Commission, Ministry of Water Resources. All these people, they calculate how much water is available. So it based on the, and this is a simple thing, the total water available in the country by the population. So now if you increase the population factor, you're going to reduce the per capita availability. So you see this 2001, we have around 1816 meter cube of water. Now it has come down to something around 1486. Okay, 1480, 1450, you can say. By 2031, it is expected to go down below 1367. cubic meters per capita water availability. Okay. So this is going to impact us in such a way that no, this is going see this is the total water availability, but at each places this will be affecting in a different way. Suppose if a state like Maharashtra where drought is regularly having, so this actually value has no significance. We have to calculate it for Maharashtra how much water is available and how much what is the population of Maharashtra. So each state will have a different impact. This is a average India uh, statement. We have to face there are four terms. One is water risk. So what is water risk? Water risk refers to the possibility of an entity experiencing a water related challenge. Now, if you see there may be water may be available, but it is less. That means in future it can go to water scarcity region. So maybe Nagpur may be having water risk problem, but water scarcity it is not there, but it is there in the drought prone areas of Maharashtra. Okay. Now, if you have a severe water stress, there is where is not enough water sufficient quality to meet the demands of the people and the industry there. Okay, so there are locations where industries does not come. So you can understand that area is already water stressed area. That's why industries don't come there. If you see that Western Maharashtra before Pune and all, you will find a lot of areas where it is already in water stress. You don't find industries there. Besides, agriculture also may not grow in those areas. Okay, then there is something, there is a value attributed to that. So water scarcity is where when the value of water per capita water is below 1700 cubic meters. Okay, per capita, whereas water stress it is about 1000 meter cube per capita, whereas absolute scarcity is somewhere between 500 cubic meters per capita. So these are all general things. It may not apply if you apply for India to Maharashtra. So individually, you have to see how much water is available. So these are the area. This slide gives the various scenarios how water scarcity will come in the future when the average temperature is rising to 1.5 degree, 2 degree. So these are all various scenarios created by the models, climate change models. So at 1.5 degree global warming, you can see the areas. The darker the shade, the higher the problem. You can see the impact of at 4 degrees global warming. So the average temperature increases by about 4 degrees. Then you can see how much area of Earth will be impacted. You may lose the entire Arctic and Antarctic region, ice cold region, Arctic and Antarctic region at that 4 degrees C. So scientists have actually worked on various scenarios how to reduce code. I'm part of the IPCC team where we prepare reports and convey to the various 200 countries are there. We send it to them for this thing. There are some countries who don't respond, like North Korea or something like that, but we send it to maximum countries where they will start working on how to reduce the climate change impact. So climate change impact is worst impacted in the islands. There are almost about 100, 150 small islands across the world which will be impacted maximum by climate change. So they are more worried, like Mauritius, Maldives, all these people are more worried and they are putting their voice regularly in these climate change forums. Whereas the big countries like USA, America, Russia, Europe, they don't talk much because their impact, they have plenty of land. They have a kind of network in such a way that they are not impacted by this system. But whereas India is not in safe zone, like India will be impacted terribly because we have a huge population and our entire economy is based on agriculture. Our service sector is only caught up since the last 40 years. So unless and until service sector overtakes the agriculture, then only probably we can say that economically we may be safe. But then climate change is going to impact India very terribly in the next 30 to 40 years. So my slides are visible.
Yes, sir, it is
Um,
visible, sir.
okay, can you see this water stress slide?
Sir.
Okay, because I am checking it regularly because I don't want people to miss the slides. Okay, this slides gives an idea about how much percentage of India is impacted by this extremely high water stress. You can see almost every part of India except the northeast and some parts of the eastern part, which has less impact. So Rajasthan, MP, Gujarat, Maharashtra, Tamil Nadu, Andhra, Karnataka. These are all, see that we need to work on this. So the in further slides, I will be explaining how we are addressing as government agencies or how we are addressing it. Okay. So government is aware that what are the sectors which may be affected. So the first and foremost thing is water cycle and demand, water quality, and water supply. These three things are going to be affected. And when these three things are going to be affected, water cycle and demand, water quality and supply, so it is going to impact agriculture, ecosystems, power sector, industry, infrastructure, human health and productivity, tourism, and business economic environment. So how is government's taking action on that? There are three things which are very important to address mitigation. Initially, I have talked about inventorization, how much concentration of gases are all there. I just gave a brief idea. But in mitigation, how government is going to do that? So government has three mechanisms by which they approach this problem. One is governing policy. They develop policies and then they implement it. They try to modify the behavior and then technology. The three things are very much important in addressing mitigation. So what are the government actions? So government has a lot of projects. There is, if any of you are interested to know what actions government are taking, you can go to website National Communication. Go and search National Communication, Ministry of Environment. There are initial national communication, second national communication, third national communications are there for India. Okay, you can open and read the entire volume. It's about 200, 300 pages. So you will have lots of charts, figures, all these things where I am part of wastewater. So you can get a lot of information related to environment, government actions on the environment and what's the current status of environment with respect to climate change. So National Mission for Enhanced Energy Efficiency, then National Mission on Sustainable Habitat, then National Water Mission, then for National Mission on Sustaining the Himalayan Ecosystem, National Mission for Green India, National Mission for Sustainable Agriculture, National Mission on Strategic Knowledge for Climate Change. So these are all various national missions. I said policies. So these are all various missions by which government is approaching to address these climate change actions. You must be aware that India is putting a lot of efforts in solar energy. So that comes under a National Mission for Green India. Okay. So, and then of course, you must have seen government giving bulbs, LED bulbs like that. So that is for enhanced energy efficiency. There are various things which are done in the last 10 years, 10, 15 years. So which is taking head on the climate change. So there are, sorry, there are various other policy projects like Jal Shakti Abhiyan, okay, which takes care of the catch the rain. Mahatma Gandhi, Manrega, this is an old project, Atul Bhujal Yojana. You can refer to these things. These are all various schemes by which universities also can tap into getting projects. These are all easy to implement. You need little technical knowledge. People are implementing it at their college level, university level, community level, and village level. Okay, these are all various projects. NIRI is also a part of some of these projects by which we do consultancy and these things. So how do we do to reduce water stress? One is first and foremost thing is educate the common folk on water, energy, and food nexus. So that's most important. Water, energy, and food is the most important by which we can tell them not to waste any of these things. Invent a new water conservation technologies. There are new, this is just a nutshell to give what all approaches we have to do. Then recycle wastewater. So industry level, we are trying to recycle wastewater, then improve irrigation and agricultural practices. Of course, when you go into community level, it is something like that. Improve water catchment and harvesting, develop energy efficient desalination plants. appropriately price water, because sometimes when you give something for free, it may not carry any value. So water is actually charged in a very low rate, but then what people don't take care of it. Once you charge it in a very right price, then people will not waste it. Okay, I'm not talking of increasing the price in such a way that people will not be able to afford it. So it should be priced in such a way that the people will take care of that thing. Look to community-based governance and partnership. There are a lot of apartment communities where they have gone for sewage treatment systems, and then they reuse the wastewater to for their gardens like that. So many people do consult us how to do that. Kya karna hai, वैसे से. So these are some things which we can do at our levels. Of course, at government level, develop and enact better policies and regulations, improve distribution infrastructure, how to improve, because there are some areas in the city where you may not get water, like slum areas, they may not get water. Then, of course, you have to reduce the waterfront footprint of our industries, the corporate, I mean, industry. Then holistically manage ecosystems. We need to engineer our system in such a way that nothing is wasted. So these are all general things. I think I will not explain too much into that. There are we have still a lot of things to discuss. We have to address these things: population growth and this thing. Yes, this is one thing. Yeah. Even when you say about climate mitigation measures, these are all various approaches how governments are using at a national level and a state level. So technologically, आप देखा तो carbon dioxide capture and storage. You must have heard in recent times carbon dioxide capture and storage, carbon dioxide conversion into fuels like methanol or any other through chemical industrial process. Then bioenergy crops, biomass, hydropower, geothermal energy, energy efficiency used in buildings, land use change and management. So solid waste management, wastewater treatment, afforestation of and reforestation, avoided or reduced deforestation. At climate change aspects, we have to cover all these things. In water management, we have to address these things. Cropland management, water management, livestock. Livestock also use a lot of water, fisheries and aquaculture. Then irrigation, water management in rice production system, development of less water intensive crops. People are working on crops which consume less water. There are rice varieties which use less water compared to the earlier varieties. Okay, so people are doing that. So for this case, how each country is approaching the problem in addressing the water resources due to impact of climate change. Three countries I have chosen. One is US, China and Africa. US being one of the most developed country, then China being a developing country, which is something similar to India. You can say they are better than India, but similar to India in terms of population and population density like that. Then Africa, it's a very poor continent. So three cases I have done. How each country is approaching this problem. So what the United States is doing is that their main problem with respect to climate change, they have put it very simple. They don't complicate things. They have three problems. One is drought, addressing drought, then addressing storms and flooding. Okay. So what they are doing is for drought, they are constructing new infrastructure. What do you say by new infrastructure? They are constructing, they are improving the existing system, and they are trying to capture water much efficient compared to the earlier one. They are constructing water harvesting, new water harvesting systems. One example of one rainwater harvesting system is constructing of check dams. That's one way. You need to increase it in such a way that now you arrest the water for a time, extra time, so that water seeps into the aquifer. So they are constructing new infrastructure. They are constructing roads also, which is having the capability to permeate the stormwater. They are designing the latest technologies they are using to change their old. The American highway infrastructure and city infrastructure is more than 200 to 50 years old. So now they are replacing the old infrastructure with new infrastructure. Of course, it's a $1 trillion expense, but they are doing it to address this drought system. They are increasing the system efficiency. How they are increasing the efficiency is that increasing the water recycling. So most industries, they treat it in such a way that they can recycle in their industry or within their own communities. They are modeling it regularly. They are having a climate models which tells them every minute what is the rain coming. So they have a huge network of climate monitoring system, which will tell how much exact rain is falling, how much is flowing in the rivers. So they are trying to have a huge dynamic database systems, and they are modeling the thing. So whatever we are seeing across the world, why America, Europe, and all, they are able to address this is they have information at their disposal. Of course, there are some cases where the uh, the cities are not able to handle issues, but that's because they have old infrastructure. So as per new infrastructure, they're trying to monitor every river, every water they are using it. Then they are modifying the land use. So they are modifying the land use. Earlier, America was giving importance to dams. Now they are trying to reduce the dams because dams are almost 100 years old. So they are trying to remove the old dams in such a way that they can bring back the old ecosystem into place. Because of dams, the ecosystems do change. So they're trying to bring the um, old ecosystem by removing old dams. Of course,
Sir, slides are again
ah,
not moving.
I think probably due to network. Now, is it
No, sir.
moving?
No, sir.
Okay. You can't see this slide? Okay. Anything else?
Now
What
we
I
can see, sir.
Yeah, probably I think network issues there. Okay, so did you see in this that there are three components which America is addressing? Okay, वॉइस तो आप लोग सुन रहा होगा, but these are the various components which their country is addressing drought. When storm, how they are addressing is construct new infrastructure. In fact, they are trying to build, some states are trying to build, levees, all these things to see that so oceans don't come into the land. Okay. These are some things which advanced countries are doing it based on their technical and technical background, and they are trying to address. The last one is water quality. So the overall source water quality gets affected due to climate change, because when you have more water, again the water quality is changed. Then when they have less water, then again the water quality changes. It's something similar to dilution and concentration. They are trying to address this saltwater intrusion, because some interiors have there was a seawater intrusion into the coast. So like in India, if you see, go to Tamil Nadu and all, you can see seawater intrusion up to 30 kilometers. So they are trying to address this issue by using treated wastewater of good quality into aquifer. So that stops the seawater intrusion into the coast. So probably because they have manpower and money, technical knowledge, they are able to address these things. Because nowadays you must be seeing in newspaper, algal blooms are occurring in water bodies, some cyanobacteria, all these unwanted algal growth are seen nowadays in some water bodies across the world. Most probably you can see this case in China, in India, you can see these algal blooms. Even few weeks back, you must have seen in newspaper that in Futala Tala, algae is choking the, that Futala Lake water fountain system. So it's because of excessive growth of algae due to nutrients present in the water. This sewage or all this runoff, they carries a lot of nutrients, and then they induce algal growth. So that's actually causing the problem and choking in the Futala Lake fountain system. So these are all known to happen when things are not going the right way. So in this case, America, it is like this. China, yes, China is slightly different. They know that the implementation in China is much stronger compared to even developed countries. They have a total control of everything. They have, if you know, China has built the world largest dam, Three Gorges Dam, that can generate almost 20,000 megawatt of power. 20,000 megawatt of power. The whole, it is the biggest hydropower project in the world. So they had, because it's a national, central planned, planning is there. So they can do these kind of things, which is not possible in a democratic systems. So they have again 5-year plans, which take control of their national water. So they do it every year. They do it every year. They have put a lot of probes into the entire water bodies. Their engineering capacity, engineering projects as well as capabilities. It's mind-boggling. If you see the projects which Chinese put, they try to start in day one, and by day 5 they are supposed to finish. They finish it on day 5. Whatever problem, they try to address it. So if you see the engineering aspect of building bridges, dams, all these things, they have a very dedicated kind of people, and that's not seen anywhere across the world. That's why China is trying to address the climate change problem, because they have a huge population. Almost their entire rivers are all polluted, because they were not following, their industries were not following all the legal requirements. Their entire water body have become polluted. So they're taking now very sincere effort to take care of their population, pollution, and ecosystems. Okay. So you must be knowing China has implemented a lot of greening of their deserts. See, they're trying to arrest the growth of deserts in their country, because the desert is migrating towards the eastern part of China, from west, northwest to, it is going to eastern part of China. So they are doing greening of their deserts, to arrest desertification of their good lands. So yeah, can you see this Africa? How Africa is addressing? Can you see this slide?
No, sir.
It's not visible. Is
Now
it visible?
visible, sir. Now visible.
Yeah, probably it is taking time. It's slow, I think, network. So Africa Africa has a huge population. They are agriculture based, so they don't have technologies and they don't have money. So they are doing in such a way that uh, they know their limitations, so they are improving all the traditional, they're trying to conserve their traditional systems. They're trying to save their traditional systems of water harvesting. They have about 30% of Africa is covered by Sahara Desert. So they are trying to invest in hydropower. They are trying to create a green wall. You can go and see the green wall in Africa. So they're trying to create a green wall by which desertification can be stopped. So these are all one mechanisms by which they are trying to address climate change issues. Yes, they are being helped by Western countries to help in understanding their real problems in terms of data, measurements, water inventories, hydrological fluxes. Europe has invested a lot of money into Africa for understanding their problems and trying to solve at local level. So if you go to an African country, there you will find all traditional kind of water harvesting. Like in India, we have one way is have I think have anybody seen step wells? Step wells. If you go to Gujarat or some parts of Maharashtra, historically step wells are there. So it is a kind of a staircase leading to a well. So people can take rest. People consume food in the past. They use the water. They take rest there, and then they move. So these kind of things they are trying to improve their infrastructure. So and they are going for traditional kind of systems. Yeah. So the last part is adaptation. The adaptation is after inventorization, then mitigation. You have the term adaptation. So climate change adaptation mainly about water. And we may talk about pollution of CFCs, HFCs, all these things, but it is basically about water. So when we say water, what are we supposed to address? As we have already seen in large number of slides, droughts storms and flooding, water quality, seawater level rise, and utility preparedness. When I say utility preparedness, everywhere water departments are there, water where corporation gives water to the, so they are supposed to be prepared for this event, drought and flooding. So if I say drought is minus, flooding is plus. So ये plus and minus को balance करना है, utility का preparedness रहना चाहिए. So how India is doing? Yes, again, similar fashions, combining the technologies and approaches of America, China, and Africa, because there is only one way of doing it. One is build infrastructure, increase the aquifer storage and recovery. Like as civil engineers, we can increase percolation basins and injection wells. We so that water can go inside the aquifer. Then we construct flood barriers to protect. Flood barriers are needed because here we use levees, dikes, and seawalls to protect flooding into the land. Okay. Alternate power is also very important. When we talk about climate change, power is one of the important component. So we try to see that instead of a centralized single facility of power generation, so which can be damaged due to a climate impact, extreme weather event. So we have to go for a distributed, decentralized kind of system like solar, wind, and micro turbines and biogas. So that's how the system can sustain in the long run. Because when you say sustainable development goals, you need to consider power also as part of that thought process. Sometimes people are relocating to higher elevation. Some infrastructure has to be taken to higher elevations. Example, suppose we have Nagpur is in a very coastal area where flooding happens regularly. So in that case, we need to construct bridges in such a way that, roads in such a way that it has to be elevated. Something like taking like what is happening in Nagpur. Nagpur, you can see flyovers are there. So we may have to increase the height of the road. Okay. The benefit is that 80% of the time you can use the roadways, bottom roadways, and some extreme weather events may you can use the elevated infrastructure. So one problem what I have been observing in Nagpur is that if you see go to Narendra Nagar, Chhatrapati Chowk and Narendra Nagar, there is one uh, railway under bridge. Every year we have been facing this problem of flooding. So yesterday, because of heavy rains, so it was just like a swimming pool. So we are not able to address this position problem. The problem is very simple. You need to pump out the water, whatever is coming from that catchment area, and immediately put it further down the canals. There are canals in the system. What has happened is the entire catchment area we have put infrastructures like houses, buildings, all these things. So the amount of water which can seep through has reduced. So that's how this flooding has been happening, and government has no idea how to solve this problem. Of course, VNIT and people they have taken information, but I don't know why this problem is not solved since last 20 years. Okay, so in a relocation to elevation, higher elevation may be one solution, like taking constructing a bridge over the line. Flooding will be there for 1 or 2 weeks, but you can construct a bridge in such a way that the traffic won't be disturbed. So this is one approach. Diversify options for water supply and expand current sources. Like we are talking only about taking water from our wells and surface water bodies, but we need to think of using recycling our water. If you go to Singapore, water is entirely recycled. Okay, if you go to Middle East, you see their entire water is ocean water. So they take sea water, they treat it, and then they use it. So we need to go into these aspects. Of course, we have a ethical issue of drinking a treated water, but whatever water we are all drinking right now is some level polluted at some point of time. So though because we are getting treated in our treatment plants, and we are also using Kent or all these water treatment units at our home, so we feel that our water is safe, but actually there is a kind of pollution in almost all water bodies happening across the world. Then increase water storage capacity. So there is one country which is doing in Japan. They are actually constructing an underground aquifer. Almost it can hold a billion liters of water. Billion liters of water. You can see. Go and check the video of Japan. underground aquifer water storage. So they collect the rainwater, put it there, and then during times of need, they treat it and then they pump it, then treat it, and then they use it. So these are something which we can use the rainwater in a different way. Like then you have to create a lot of low head dams. Low head dams, it's not applicable to Nagpur, but at least in coastal areas where you need to have a small dam so that salt water is not intruding into land. Of course, we have to diversify options for water supply and expand current sources. Build flood barriers to protect infrastructure. Like what this in this case, आप लोग सुना होगा in Gujarat Sabarmati front. You can go to Sabarmati front on YouTube and check about why that was built. Now you go to Dravyavati River in Jaipur, why it was built. So you need to build these kind of infrastructure to protect our infrastructure. Like Nagpur, we have some areas which is regularly flooding. So those areas we need to go for this kind of riverfront development. We need to develop so that the water is arrested only in that area so that it will not break outside the area. So these are all essential things which we have not thought in the last 50, 70 years. But now I think governments are all very much interested in going for this kind of infrastructure. So of course, this here we need to go for system efficiency. Like how do we increase the efficiency of water availability is reuse and recycle water. There are various approaches by which we do it, but I am not going into details of that. Then we have to monitor. So monitor means you have to generate data. So how much, what is the weather, what is the rainfall pattern, how much water is going out of a region. All these things, you have computers, probes, satellites, all these things can give minute to minute reading of these things. These are already there in India also, but we need to improve their facilities into the future. Of course, there are agencies like Indian Institute of Tropical Management. They work on the models. They develop models to address these climate change issues. They have been doing it. Then they do analyze their so position in such a way that how do we address it? So they give policies and technology, inputs to the government so that over a period of time the intensity is in manageable level. Okay. Modeling is very important part of the climate change activity. Without modeling, it's very difficult to comprehend what is happening in the planetary level or at regional level. Regional level is very small thing. For that also, it is very difficult. But planetary level, it's mind-boggling efforts. About the team which I am working is that about 35,000 scientists, engineers, science people. They're all working across the world. I am part of the group from India. So they're all working at their own levels, a contribution to the government. Government takes this policies, all these things are. So across the world, there were 35 to 40,000 people who are working directly and indirectly in the field, in this field. And there is a lot of scope for working in climate change areas. You can, even if you don't need to show that I'm working in a climate model, even if you're doing a small level, like a planting of trees, forestation, there also is going to contribute very significantly to the climate change aspect. Of course, we have to, here I am in this slide, we have to address water demand. How do we address water demand is to reduce agricultural and irrigation water demand. One way by which we can achieve this is that now you must have heard the term hydroponics and vertical farming, micro irrigation like that. So if you go after these things, the amount of water used for agriculture will be significantly reduced. Up to 90% of water can be conserved. I have few friends who are doing hydroponics, generating their own food. But of course, it involves a lot of time and technological challenges are there. But then they are happy doing that as a kind of a hobby. So, but at national level, how it is going to work and all, I think you need to test. There are a lot of studies which are needed from this aspect. Probably Nagpur University can look into these things, how irrigation can help. These kind of modern approaches can help food security in our country. Then of course, the last one being modify land use. So everywhere we have converted our water bodies into buildings, roads, highways, all these things. So we need to retake, give them the lands to those native things which was already there. We have to create mangrove systems, saltwater marshes, wetlands. We should not disturb that. Probably we need to address it back in such a way that drought and flood systems will be mitigated in future. Okay, there's one thing which cities can do is that implement green roofs, green walls. I think if you see the bridges in Nagpur under for the G20 program, you must have seen green walls where plants are, the bridge, both sides of the bridge, you can see plants being watered. So there are some approach, small level things which can improve the climate change, contribute to the climate change activity. So the this slide, it gives the develop coastal restoration plans, then identify and protect vulnerable facilities. There are vulnerable facilities across the state, across the city, like pump station, water pump stations, power generation units. These are all dependent on water. Pump station is where they pump water for the city and wastewater to the sewage treatment plants. Power generating units are nothing but the thermal power stations which need huge quantities of water. So they need to be addressed for the impact which is going to come because of climate change. Okay, you have to develop the emergency response plan. Of course, many of the top power plants, they have developed their own emergency responses. But nature throws them challenge every now and then. Today, you develop a plan for some 10 millimeter of rain. Tomorrow, it will rain 10 centimeters. So you need to keep on upgrading and updating these plans. Okay. Then, of course, the most important thing in addressing water resources and climate change is repair and retrofit facilities. What's going to happen is that because if it is flooding, like we don't know what is going to happen in Nagpur in the next 10 years. If it is raining excessively, probably our water, so much water will come into the sewage treatment plant, so much water will come into our drinking water treatment plant. So we need to redesign the systems in such a way that that amount of water can be treated and stored before supply. So these kind of small decision levels, administration levels, city levels, regional level and country level, people take decisions. Yes, retrofitting is important. Then increase wastewater capacity and stormwater collection and treatment system. So yes, the previous slides have told everything about mitigation, inventory, restoration, adaptation. What are the softwares which are used for water resources management? I think these softwares are all pretty easy to operate. Just a little bit of mathematics and technical knowledge is required. So we use these things like GIS. Of course, GIS is a general thing. It is a geographical information system. We use GIS for addressing the area, all these things, land use, all these things. Then we have softwares like GeoHecras, IRIC, PRMS. All these softwares are used. Hydrogeological modeling, ModFlow, Mike Nampeg software. We use that for river flood modeling. So dam break softwares are there. So we use all these things to understand what is the impact of water resources at that and predict it and keep it. Like Mike Hydro, we have 2D and 3D models. Slosh is one model where which does the sea lake and overland surges from hurricanes. We have a tornado or something like that. How much water can come inside? You can predict. Then open foam software is there, which is you can do it based on your own mathematical concepts. So that brings an end to my presentation. If anybody can put questions, I think I will be happy to answer that. Are there any questions? Are there any questions? Hello?
Hello.
Are, yes. Are there any questions? Actually my presentations are over.
I'd like to ask one thing, sir. Sir, due to climate change, somebody is telling we will be getting monsoons very often, sir. Is it so? If it is like that, means it will solve your water scarcity problem, sir.
That's what I said. No, like yes. Actually, government is working in understanding how it is going to impact in each region. Like Maharashtra, we have Maharashtra remote sensing in Nagpur. So government is working like what is going to happen, because it's very difficult to predict what is going to happen to a place. Some places we may think that it's going to have heavy rains in this region, but it may not happen. There are that ecosystem is very dynamic, and weather is very dynamic system. Climate change is a very dynamic system. So, yeah, now if we understand, if we come to conclusion based on models and data and models, so we come to conclusion that it's going to increase in rain over a period of time. Now you have to, as I said in my slides, you have to retrofit your infrastructure. If it is raining heavily, your infrastructure is going to be damaged. Example, more water is going to come into your roads, more water is going to come into your sewage system, more water is going to come into your water treatment plants. Okay? So now you have to address it in such a way that now you have there is no single way approach to solve this. So first thing what you can do is, if it is going to rain more, so best and easiest approach is put the maximum quantity of water into the aquifer. Just put maximum quantity into the aquifer. So increase rainwater systems in your area. So when you put most of the stormwater coming into your area, you can address almost 50%, more than 50% of your problem of flooding. Flooding position change ho jata hai. So the rest 50% or 25%, whatever it is, you can address it through improving the infrastructure. You design the system in such a way that now all the water which is collected in the city can immediately run to the nearest canals. Like we have nallas, canals are nothing but nallas. So immediately it should be connected to a nallas in such a way that they can immediately go to the nallas. Thereby, there won't be any flooding. But what has happened in India is, because people are dumping solid waste management, that nallas are all not maintained and nallas are encroached. The nallas actually are encroached, and because they are already full of waste, so it is now causing a flooding in the city. If all the nallas are clean, there is no debris. That's why every year you can see Nagpur administration tries to remove the clogs in the nallas. Across the city, they will be dredging the riverbed. They may be clearing all the solid waste from the nallas, so that the river can immediately, the stormwater can immediately move from the city. So these are some things which we have to do. I think I addressed your question. Did this address your question? Hello? Did this address your question? Can you hear?
Yes, sir, your voice is audible. No?
Yeah. So did this answer my question? Actually, some participant asked this question, but
Uh,
yeah, are there any questions?
I would like to request rest of the participant, please go on interacting with our guest speaker.
So, sir, it has been said that till 2050, the many cities in India will be submerged. So, can we avoid that? What will be the status? Really, it will be going to happen.
It may not be the case. Like I'll tell you now, like when I shown one slide, India may there are almost 70% of our land has drought problem. I showed one slide in which how much percentage of Indian land is having drought problem. So flooding, that's what I said. Now flooding happens because of rapid urbanization, population growth. You have an unplanned kind of management system. That's how flooding happens. So if you say that entire India will be flooded, it's not possible. It's not at all possible. Like since last 2 days, it is raining in Nagpur. Flooding has not occurred across the city. It has happened one or two places, and they are all regular offenders. Like one Narendra Nagar rail under bridge may bola. So this problem is there since 20 years. It's got nothing to do with the climate change. It is improper infrastructure and improper. There is no proper idea coming out of how to address this issue. We don't have an idea. Of course, organizations have given approaches to solve this problem, but it's not working. So as per your question, I think India is going to be flooded. Yes, there may be some cause of flooding in some states which are very near to water bodies, but it may not happen, because governments are aware of all these problems at state level and national level.
Okay, sir.
Sir, I
Any
was
other
curious
questions?
on asking the question, sir. You explain, you answer my question, sir. Thank you, sir. I can't able to unmute by that time.
Okay, okay. So, what was your question? If you want, I can repeat it.
So no issue, sir. I can able to hear, sir. I just can't unmute and answer, sir.
Okay, take
Okay,
it.
thank you, sir. Okay, sir.
Anybody would like
You-
to ask any question?
Thank you, Dr. Praveen. Actually, क्या है? This presentation Nagpur University के लिए I don't know because I'm working for climate change project with MOF. No, so most of my presentation material it is something what the government is doing and what we are doing, like what activities we are doing. So I don't know how much level this may have addressed your need, but these are all the approaches which agencies do that to this chapter actually, this topic is something like which can go for 6 months. I can take in each and every objective which bullet I have showed, I can explain it for 1 or 2 days. So this is a very, very big topic. So to condense it is slightly this thing. I
It's a
say.
difficult
So I
task.
don't know how it might have helped you, but then these are all things where you can get a lot of projects. As an independent worker, you can get as a technical, as a socio-economic worker, and then psychology. Psychologist also has a good role in this climate change roles because disasters occur, and when disaster occur, you need definitely a psychologist to address this issue. A lot of opportunities are there for this business, climate change activities.
Okay, sir. Okay, thank you.
So can
So
I?
suppose there will be no question.
Sir,
Hello.
one question only.
Yeah, please.
Hello.
Dr. Suparna, please continue.
Sir, when I went to Andaman and Nicobar, I saw there that everywhere there is this island is surrounded by the water, but still one river is there in Andaman, and which is used for the water is used for drinking water. So
Okay.
my question is to you, sir. Yes, though it is surrounded by the water from all the sides, nowhere there is a source of any good water or say potable water. But even though that river is surviving means from various years,
Yeah.
so how this is possible, sir?
This is nothing actually. Actually, you must have heard the term aquifers. So we have
Yes.
aquifers, like even in our, if you go to hilly areas, there will be good water coming out of the mountain, oozing out of the mountain. Okay. So the aquifer waters are sometimes very clean, and it's good for consumption. There are a lot of locations across the world. You can find a lot of aquifers which will be giving good quality water. Actually, what is happening right now is that we are polluting all those aquifers. Aquifer means underground water, can say
Yes.
underground water storage. Okay. So this is not a big deal. I don't know, but how long we will be using that water, and what will be the status after 50 years or
Yes.
100 years? That's a point to
No,
be
sir,
talked about right
they
now.
are saying, the people there are saying कि ये भगवान का चमत्कार है.
नहीं कोई भगवान चमत्कार नहीं है. Practically speaking, no, everything is understood in civil engineering and science. There is no chamatkar in this.
We know this.
Any religious places also, you go to Himalayas and all, I see that Shivling जैसा कुछ होता है. There is no actually religious. वो people blind इसमें वो बोलते. The reality is that because water droplets are falling from the top, and because of cold weather, that forms into a kind of a crystal, water crystals banta hai. So there is no, it is pure science. Actually, people attribute spiritualism to that, but it's pure science.
Yes. Things are there various in islands. There are rivers because of that aquifers, which are very always filled with the pure water and rainwater also.
Yeah.
Okay.
But we need to protect those aquifers. Like in Srinagar, I had gone 4 or 5 years back. So there is one mountain from which good, very high quality water comes out, totally crystalline. Matlab, you don't find turbidity. Itni clean rehta. So directly you can drink that water. So from mountains, that's due to aquifer because water flows through the soil So that is a major thing. So there are studies to find out where aquifers are there, aquifer lines are there. All these things, studies are there. People do it. There is nothing unbelievable thing about that. Once you understand it, then you will feel that, "Arey, kuch nahi hai."
Yes, sir. Okay, thank you, sir.
Yeah, yeah.
So, sir, I, on the behalf of the UGC HRDC Center, I wish to extend my sincere thanks to you for accepting our invitation and sparing your valuable time for us and enlightening all the participants with your excellent presentation. Thank you very much, sir. Now, I would like to request Ms. Kanimozi for further proceeding.
I would like
Ms.
to thank you,
Kanimozi.
sir, for yes, sir. I would like to thank you, sir, for giving a brief description about the greenhouse gases and the reason for increase of greenhouse gases and its effects on climate change. Sir, you also mentioned how climate change results in extreme weather condition, biodiversity loss, increased health risks, and displacement of people, which can be tackled by mitigations and adaptations. You have also described some approaches and methods like considering government policy, behavior, and technology to mitigation in reducing water stress. You also explained some case studies about usage China and Africa in managing the mitigation problem. The role of various softwares in addressing water resource management was also listed in this presentation. I once again thank you, sir, on behalf of everyone for sparing your valuable time with us and giving an excellent presentation. Thank you, sir.
Thank you, Dr. Praveen and
Thank you, sir.
Dr. Kanimari for the invite as well as giving me opportunity to share our experience. Thank you very much.
Thank you, sir. Thank you.
Yeah,
Again,
thank
we'll
you very
meet
much. Can I
somewhere.
leave?
Yeah,
Ah,
sir.
yeah,
Yeah,
sure, sure.
yeah.
Can I leave?
Yes, sir. Yes, sir.
Okay, okay. Thank you, Dr. Praveen. Yeah.
Okay.
Sir, your voice is not audible, sir.